this example, we're going to look at something that covers case 3. So case 3 looks identical to case 1. The only difference is that this equation is not factorable. So let's pause for a second and talk about what that means. So if this was a case 1 example, we would start by thinking of two numbers that multiply to 3 and add up to 5. However, what you will soon find out when you try to do that is that there are two integers that multiply to 3 and add up to 5. If you list out all the factors of 3, which are only 1 and 3, they just add up to 4. So at that point, you should understand that you have to solve this using another method. So we can't factor it. So it's not factorable. So what we're going to do is we're going to use the quadratic formula. So the nice thing is that this is already written in standard form. So if I match it up with standard form, I have that A is equal to 1, because I can put a 1 on this. B is equal to 5, and C is equal to 3. And then I'm going to go ahead and use the quadratic formula. You guys should know what that is. You should have it memorized. You should have learned that in Algebra 2. I don't have a video of how to derive it, but I might put one up later on this year. And I'm going to go ahead and just use the formula. So I'm going to have negative b, which is going to be negative 5 plus or minus the square root, b squared, which is 5 squared, minus 4 times a, which is 1, times c, which is 3, all over 2 times a. And then we're just going to simplify. So we get negative 5 plus or minus the square root of 25 minus 12 over 2. So I get negative 5 plus or minus the square root of 13 over 2. And I'm going to split that up into two separate fractions. So I'm going to have negative 5 over 2 plus or minus the square root of 13 over 2. You could go ahead and plug that into your calculator to get your two approximations, but I'm going to leave it as this for this example.